Good morning, class. Today we're looking at paper one, the PLM paper that you guys have written. At this point, yesterday we needed to calculate in. Okay? So the first step was to cross multiply. So I'm going to get 2 million multiplied by 0,092 over 12. Then I divide it by 2,000. Okay? With that, I would have gotten rid of this bracket plus 1. So that is equal to 1 plus 0,092 over 12 to the exponent 12. Okay. So the left hand side of that equal sign I'm going to put on the calculator. So divide by 2,000 plus 1. 26 over 3. This 26 over 3 is equal to 1 plus 0,092 over 12 to the exponent 12. So as you can see, the unknown is in the exponent, so it's 12 n is equal to, I'm going to use logs, so it's log 26 over 3 base 1 plus 0,092 over 12. That gives us, so we'll go with that log, 1 plus 0,092, that's over 12, that is 26 over 3. That's 282,75. 282,75. That is payments. If they ask you for years, I would have divided by 12. So it's a question. After how many years will the investment be worth? 2 million. So I should divide it by 12. So therefore n is equal to, you get answer divided by 12. Going to give it 23,56. So therefore 23,56, approximately 24 years. Okay. You guys understand? Is there any confusion there? Okay. So now we're moving to the graph section of the paper. Question 5. So what I'm going to do is I'm going to take a calculator over here. And the video there. Okay. So we get a bit more here to play around with. So we are told the sketch represents the graphs of, let's just write the graphs here. F of x is equal to k to the x plus m, and g of x is a into x plus p squared plus q. The two graphs intersect at a, which is 0 and 2 there, and g touches the x-axis at 0 and 3 there. The coordinates of B is 1 and 5, which lies in the graph of F. Okay. With that, I can get rid of this here. It doesn't want to be hidden. So put this here. Right, first question. The question says, determine the values of A, P, and Q. So A, P, and Q is part of the graph of G, which is the parabola graph. Can you see that? So what do we have on the parabola? We have that 3 there, and we have 0 and 2 for your y-intercept. So we know that your turning point is going to be that PQ value. That is your turning point. Okay? So that means to say that P is 3 and your Q value is 0, of course. So your equation is y is equal to a into x minus 3 squared plus 0, which is 0. To calculate a, we'll substitute the point that's lying on this graph, which is 0 and 2. It's the x and a y. So I have 2 is equal to a into 0 minus 3 squared. Okay, that's going to give us 9a, of course, is equal to 2. So a is equal to 2 over 9. My equation now is y is equal to 2 over 9 into x minus 3 whole squared. Okay. I'm going to replace g of x with that equation. I'm going to multiply this out. I'm also going to be getting 2 over 9x squared. That times 2 is going to give you 6. 12. 4 over 3. So you get the 4 over 3x plus 2. If you need to multiply that. Okay. So we got the a value, we got the p, and we got the q value. Okay. You would agree with that? Again, the question paper and memo can be found in the description box below. The link to it. Okay. Let's look at 5.1.2. Question 5.1.2, we are told determine the value of m and k. As you can see, m and k belongs to the f of x graph, which is your hyperbolic graph, your exponential graph there. So we have 2 points on that exponential graph, which is a and b. So normally we substitute what's on the y-axis first. So we'll substitute a, which is 0 and 2, into f of x. Okay. Remembering that's x and a y. So what do we have? 2 is equal to k to the 0 plus m. So m works out to be 1. So anything to the power 0 is 1 and 2 minus 1 is 1. So f of x now reads f of x is equal to k to the x plus 1. Now I substitute the other point, which is b, which is 1 and 5. That's the x and the y. So 5 is equal to k to the 1 plus 1, which makes k 4. So what's the equation of f of x now? So f of x is equal to 4 to the x plus 1. Okay. Five point 1.3. Question 5.1.3, they want to know how you transform the graph of g of x to represent the graph of h of x equals a to the x squared plus 3. So if you're looking at the a, what is a, people? What's the value of a? 2 over 9, because we've solved that already. So in other words, h of x is going to simply be 2 over 9 x squared plus 3. But remember, what is g of x? What is g of x? G of x is defined as 2 over 9 x minus 3 squared. So what must happen to g of x to get that h of x out? Firstly, I need to cancel out the 3, not so. So how do I add 3 to this? You must shift the graph 3 units to the left. So you're going to shift g of x 3 units to the left. If I do this, okay, then that is y is equal to 2 over 9 x plus 3 minus 3 squared, which simply gives us 2 over 9 x squared. Is that what h of x is? Not yet. Then what happens to the graph? Then the graph shifts 3 units up. Then shift graph 3 units up. By doing that, you'll get y is equal to 2 over 9x squared plus. There was 2 marks on the sum. The one is lying there. The other. Okay. Let's look at the next question. In 5.2 we are told, given the quadratic function y is equal to x squared plus 8x plus b, the minimum value is minus 3 and passes through 1 and 1. Find the values of the constants a and b. So the quadratic function has a minimum value. The minimum value is minus 3. So that means to say the graph is smiling and there's a minimum value, some x and a minimum value of minus 3. Okay. So what we do is, and the graph passes through 1 and 1. So what we do is we substitute 1 and 1 into the equation. By doing that, I'll get 1 is equal to 1 squared plus a times 1 plus b. So b works out to be, that cancels, minus a. That's equation 1. Okay, they have taken that into account. Now let's look at this here, the minimum value minus 3. So if you look at this here, it has a minimum value, so I need to complete the square. Because if you look at y is equal to a into x minus p squared plus q, if the a is positive, then the q value will be its minimum value. Not so. And if a is negative, the q value will be its maximum value of the graph. Okay. So we need to get it in that form first. So we got y is equal to x squared plus ax plus a number to complete the square with, minus that same number plus b. What is the number in this case? It's going to be b times a half, which is a times a half, which is a over 2, and it must be squared, which is a squared over 4. A squared over 4. And this here is of course equal to negative 3. But before we go into that thing, we just write it in the proper form there. So it's x plus a over 2 squared minus a squared over 4 plus b. And this, as I indicated, is your q value, in other words. So you say therefore minus a squared over 4 plus b is equal to minus 3, and this is equation 2. Okay. From here it's simple. Simultaneous equations. Just to be, if I see a b up with a minus a, so it's sub equation 1 into 2. So it's minus a squared over 4 plus negative a equals minus 3. Multiply throughout by 4. So it's negative a squared minus 4a minus 12 becomes plus 12 is equal to 0. Here the quadratic formula. We can divide it by a. We'll use the calculator. So if a is negative 1, so negative 4 and 12, of course. But a is equal to 2, or a is equal to negative 6. Okay. But of course, your b value. So b is equal to negative a.
Interruption. Is Sona Tisani? Can you please report to the office? Is Sona Tisani? Can you please report to the office?
Any of you guys here? No? Okay, so therefore P is equal to -2 or P is equal to 6. Okay. And there was 5 marks of 6. How many marks there? 5 marks on this question. Okay. So I marked it as follows. Um, I gave you 1 mark for getting the first equation out. Equation 1. Actually 2 marks. One for subbing that coordinates in there, and one for getting that equation out. Completing the square. Gave you 1 mark there. Okay. And then 1 mark for your A's and the B's. 1 mark. So it's 5 marks. Okay. Let's look at the next question. Question 6. In question 6.1, you are given f of x equal to -5x squared. Restrict the domain of f so that the inverse of f will be a function. So if we're looking at this graph here, what do we do? Okay, so this is a quadratic function. Okay, so you see me drawing the table at this point here. So this is a quadratic function. The graph is going to look something like that. Not so. So if I reflect this graph, of course it's going to do that. So is this inverse a function? No. So what do? I need to restrict the domain of the function so that inverse can be a function. We say x has to be greater than or equal to 0, or x has to be less than or equal to 0. People both must be written down. The people who got the 1 mark there only wrote one of the two down. Okay. Let's look at 6.2. It says write down the inverse of f in the form of. This is supposed to have been y. I made a mistake there. Because the inverse of f is not a function. Okay, but you're not going to lose in the mark there if you had written f to the -1. So that's my mistake there. But for the inverse function, what do you do for the inverse function? You interchange x and y. So x is equal to -5y squared. So I divide by -5 both sides. So y squared is equal to x over -5. Square root here, so it'll be plus minus the square root of x over -5. If that asks you for a restriction here, x has to be less than or equal to 0 here. Okay? Because under the root, you must can't get the negative value. Okay? So x has to be negative for that resultant under the root to be positive. For those of you who use logs there, people, this is not an exponential function. It's a quadratic function. The other question says, sketch the inverse on a system of axes. Okay. So what we do is we draw y is equal to -5x squared. If we draw a table for this here, so that will be x and y -1, 0, and 1. So that's going to give you -5, 0, and -5. So if I go for the inverse function, so we just interchange those values. So it's -5, 0, and -5. Okay, so 0 and 0 remain 0 and 0. -1. So it'll be -5. And 1. And -5 and -1. So that is the inverse of that function. Okay. Any confusion there? No? It's easy, no? You see somebody else do it. Right, people. Question 7.1. The function illustrate the function y is equal to f of x is illustrated alongside. Okay, so Sketch a graph of the functions given in the questions below. Also indicate on the sketch the asymptotes and the intercepts of the axis. Let's look at the first one. So if we're looking at y is equal to negative f of x. People, what is that? If you put negative in front of the y, what's actually happening there? So this is reflected in the what? X-axis. Reflected in the x-axis. If something is reflected in the x-axis, what happens? Y becomes negative. So all the y values become negative. So that's y is equal to negative 2. Not 2, sorry. Now becomes y is equal to negative 2. So we're going to use the red here so that you can see it clearly. Y is equal to negative 2. So you see this x is equal to minus 4, what's that? Minus 4, minus 1? Minus 1. That is unaffected, not affected. Not affected, okay. So, this point here of negative 2 and 0 remains negative 2 and 0. So this asymptote remains of x is equal to minus 1. That asymptote remains. This point here of my 4 becomes negative 4. So there I can draw the graph. Enough information to draw this graph. So that's what the graph is going to look like. Okay, we just draw it on the side here. This x equal to minus 1. Y is equal to minus 2. That is of course negative 2 and that's negative. Okay, you guys understand? Right, let's go to the next question. The next question says, you got f of x, y is equal to f of x minus 2. What effect does this have on the graph? The graph going to shift 2 units to the right. Not so. So if this moves 2 units to the right, will it affect this line y is equal to 2? Will it affect this line here? No. Would it affect your horizontal, your vertical asymptote of x equal to negative 1? Yes, because the graph is going to move 2 units in that direction. Yes, the graph is going to move. That asymptote will move. So if I move 2 units to the right, then it becomes x is equal to 1. What else will move? This point here. If I move it 2 units to the right, it's now going to go through the 0 marking. Not so. So there's my graph coming through. Like that. And of course the graph going through like that. Okay. 3 marks on each one there. 1 on the asymptote, 1 on the intercept, and 1 on the shape. Okay. People, the graph of an increasing exponential function. Increasing exponential function can either look like that or like that. One of the two. Okay, that's how your graph should look like. The graph of an increasing exponential function with the equation f of x is equal to a times b to the x plus q has the following properties. Y is greater than negative 3. Okay, so of course, it can't be this one, so that has to be a less than. So y must be greater than negative 3. Okay, so what does that mean to say? That means to say that my q value has to be negative 3. This was your horizontal asymptote. So your q value is negative 3. The point 0 and negative 2. 0 and negative 2, which is your y-intercept there. So that is actually your x-axis here. This is your horizontal asymptote of y is minus 3 there. That is your 0 mark in there. That's your y-axis. X-axis. Okay. The point 0 and minus 2 and 1 and minus 1 lies on the graph of f. So if I look at this function, I got now f of x is equal to a times b to the x minus 3. So how many unknowns do I still need to solve? 2. So I need 2 points on the graph, which I do have. So I substitute the one that's lying on the y-axis first. That's the x and the y, of course. So negative 2 is equal to a times b to the 0 minus 3. Anything to the power 0 is 1. So a is equal to 1. So now my equation reads f of x is equal to 1 times b to the x minus 3. So what do I still need to solve? B. So you substitute 1 and minus 1. That's the x and the y. Okay. So negative 1 is equal to b to the 1 minus 3. So b is equal to 2. So what's my equation now? Therefore, f of x is equal to 2 to the x minus 3. Okay. 2 to the x minus 3. Is there any confusion? Then we are told that describe the transformation from f, which is this equation, to h of x, if h of x is equal to 2 times 2 to the x plus 1. So firstly, what you should note here is that has the same basis there. So h of x could also be written as 2 to the x plus 1, as there are 1 there, plus 1. Okay. So how do I move from x to x plus 1? The graph must move 1 unit to the left. Okay. So remember, you must end off with that. So you'll shift f of x 1 unit to the left. By doing that, my equation now reads not f of x anymore, but y is equal to 2 to the x plus 1 minus 3. So how do I get from minus 3 to 1? The graph is moving 4 units up. So you shift the resulting graph, shift 4 units up. By doing that, you got y is equal to 2 to the x plus 1 minus 3 plus 4, which now will result in h of x is equal to 2 to the x plus 1 plus 1. Okay, 2 marks on the sum here. 1 you'll get there, 1 you'll get there. Do I need to show this in between? No. Okay, let's just do that to show you actually what's happening to the equation. Okay, people, a limits question doesn't come in often, but you need to know it anyway. So that it needs to be factorized first. Okay, so we don't drop the limit until we do the substitution. So you can factorize the difference of cubes there. So the cube root of x cubed is x minus the cube root of 8 is 2. So I square the first time, I get x squared. That times that in the opposite operation, so it's 2x. The last term squared over, and I swap this around, becomes negative x minus 2. That of course cancels. Leaves you the limit as x approaches 2 of negative into x squared plus 2x plus 4. So if you ever see an x, I put the 2. So that's negative into 2 squared, which is 4, plus 2 times 2, which is 4, plus 4, which gives you 12. Give me an answer of negative 12. Okay. As you can see, we substitute 2 straight into this here. It will give you an undefined solution. People, from first principles, differentiate P of x from first principles. So the formula that needs to be followed is P dash x, P prime x is equal to the limit as h approaches 0 of P of x plus h minus P of x all over h. So we go the limit as h approaches 0. We do not drop the limit until you do this equivalent substitution here. So if P of x is 2 over x in the negative, then P of x plus h, of course, is going to be negative 2 over x plus h. So I got negative 2 over x plus h minus negative 2 over x, and this is all over h. So you got the limit as h approaches 0. Negative times negative, of course, is a positive there. So it's negative 2. It's going to give you a positive. Alright, so what's my LCM here? It's going to be x into x plus h. And this is divided by h over 1. So we got 2 into x plus 2 into x plus h. Okay, so we got the limit as h approaches 0 of negative 2x plus 2x plus 2h all over over x into x plus h multiplied by 1 over h. Of course, that cancels. So I'm left with 2h over x into x plus h times 1 over h. So that also cancels. And if I see h up to 0, so what are we left with? 2 over x squared. Okay. That was your 5 marks there. Okay. In 8.3, it says differentiate the following functions. Expressing your answer with positive exponents when necessary. Pay careful attention to notation. Okay, so firstly we need to get it in the form of a to the x raised to the n. As you can see, the first one is not in that form. So I need to write that insert in the exponential form. So it's 6x. There's a 1 there, of course, on the x, so it's 1 over 3. Now we can say dy over dx, the derivative of y with respect to x, is now going to give us 6 times a third is going to give you 2x minus 1 is minus 2/3. As you can see here, that is only on the x. So only the x will go to the denominator. Okay, only the x goes to the denominator. So that is simply going to give us 2 over x and to the exponent 2/3. Okay. The next one. So the derivative of x. So as you can see, it's already in that format. So we multiply the exponent with the coefficient. The 3 times pi is going to be 3 pi. Minus 1 there is going to give you 2. Then pi times 1 is pi. X minus 1 from that, I get pi minus 1. Okay. Or you can change the 3,14. I think you got the 2.14. That I accepted as well. Okay, so the graph of the cubic function, which is f of x is equal to negative x cubed plus bx squared plus cx plus d, and the straight line g is shown below. Not drawn to scale, as we are given a to be negative 4 and negative 36, and d are the turning points of f of x. PQ is parallel to your y-axis. So since it's also perpendicular to the x, it's also the same thing. Okay. Take that out. Take that up. First question. Question states, find the equation of the graph proving, supposed to be that, f of x is equal to negative x cubed minus 5x squared plus 8x plus 12. Important to note, you may not assume the result in your working. What does that mean? That means you say, I can't use that in order to prove it. So some of you use that and you prove that A was the turning point. You're not going to get any marks for that. Alright. So, what do you notice here? The graph is going through 12. So of course, D is equal to 12. Not so. So y-intercept. Alright, so what do we do now? We say now f of x is equal to negative x cubed plus bx squared plus cx plus d. People, how many unknowns are there? Plus 12, sorry. How many unknowns are there now? 2 unknowns. So I need at least 2 points on this graph. Okay, with 2 equations, sorry. I need to set up. So from here, as we know, it's a turning point. So what do? I find my derivative. So f prime x is equal to negative 3x squared plus 2bx plus c. At the turning point of A, f prime of negative 4 is 0. So that's what's your turning point. Why? Because at the turning point, your derivative is 0. So you say 0 is equal to negative 3 times negative 4 squared plus 2b times negative 4 plus c. So that's going to give you negative 3. Whoops. You get negative 3 times 16. You negative 48. So C is going to be plus 8b minus plus 48. Okay, that's equation 1. So what I do is I take that same point and I substitute A, which is negative 4, and negative 36 into the equation of f of x. Okay, remember when you put the x in, you get the y out. Okay. So I'm going to plug it into that one there. So negative 36 is equal to negative 4 square cube plus b times negative 4 squared plus c times negative 4 plus 12. Okay. So that's going to give you negative 36 is equal to, the calculator is negative open brackets, negative 4 to the exponent 3, just 64 plus negative 16b minus 4c plus 12 is equal to plus 12. Okay, so you got now negative 36, negative 36 minus 64. Oops. Negative 36 minus 64 minus 12. Negative 112 equal to 16b minus 4c. So I'm going to divide throughout by negative 4. So c, now 16 divided by 4 is going to be negative 4 is going to be negative 4. Take it over the equal side. I get positive 4b. Negative 112 divided by negative 4 will give you 28. This is equation 2. Okay. So equation 1, equation 2. So you set equation 1 equal to equation 2. So I now get 8b plus 48 is equal to 4b plus 28. You get over the equal sign. So 4b is equal to 20. And the negative. So b is negative. Which confirms that. So we got c is equal to 8 times negative 5 plus 48. That's going to give you negative 40 plus 8 is 8. So therefore, f of x is equal to negative x cubed minus 5x squared plus 8x plus Okay, easy. 6 marks there. Guys, can't believe it's so easy, huh? Yeah. So let's look at the next question. So I don't need this here. Let's take all of this off. So the next question says, pull the next question out here. There's some interpretation questions with regards to this graph here. So 8.4.2, find the coordinates of the points of inflection. So how do you work out the point of inflection? Second derivative. So if prime or double prime of x is equal to, so that's going to give you negative 3x squared, which is negative 6x, minus 10x, so it's minus 10. I say that equal to 0, so x is equal to negative 10 over 6, which is negative 5 over 3. And then substitute negative 5 over 3 into the original function. So it's negative into negative 5 over 3 cubed minus negative 5 over 3 squared plus 8 into negative 5 over 3 plus 12. That gives me an answer of negative 286 over 27. Therefore, the point of inflection is negative 5 over 3x and negative 286 over 27. Okay? So hopefully in tomorrow's lesson, I was hoping to start paper 2 tomorrow, but it doesn't look like it will happen. We need to wrap up this paper first. Okay? People enjoy the rest of your day.